Hey, hello, welcome to my channel. Now in this video, we're going to learn how to differentiate an implicit function, right? But at first, I'll tell you what an implicit function is. So an implicit function is a function of the form f of x, y equals to lambda, right? Good. Okay, with that lambda there is just a constant. I know you're used to this notation. Whenever we have f of x, okay, equals to y, that means that y is a function of x. And here we have this place to be just x, okay? But this one, we have it to be x, y, which means this is a function of two things, x and y, all right? So we can call that a function of two variables, all right? So here was just a function of a single variable. Good. Okay, so here we have it that an implicit the function of that form, okay, in which one of the variables in there is a function of the other variable, okay? So if we have something like this, where one of them is a function of the other, for example, here, the first example here, we have x squared plus y squared equals to 1. So this is a function of two variables, x and y, all right? And y here is a function of x, okay? So maybe if you want to rewrite this using that fact, we're going to rewrite that as f of x. Then in place of y, I can still put it down as a function of x, all right? I put it down where y is just the g of x. Good. So an equation of that form is called an implicit one, okay? Like the second example, we are writing this function in terms of x and y, right? Unlike when we say y equals to x squared, y equals to, let's say, x squared plus 1, and we are asked to differentiate that. But in this case, we are writing the equation on the left-hand side in terms of both x and y, right? Where y is a function of x. Good. Okay, maybe let's learn how to differentiate this kind of function, okay, called an implicit function, okay, just by using the example which I'll be writing down in the next part of the board. All right, good. So here we are given that if x squared plus y squared is equal to 1 and y is 2x plus 1, then we have to find the y, the x. Good. Okay, so from that question there, we are given the main equation, all right, and then we are given something else here that y is 2x plus 1. Well, I am going to ignore the fact that we can substitute what y is in there and just try to work with it, all right? But I want to show you how we apply the chain rule, okay, in these implicit kind of functions when you want to differentiate it, okay? So what I will be doing here is we will start with this as the main equation. I'll just put it down as x squared plus y squared is equal to 1, all right? Good. Okay, so when we have it that way, okay, to differentiate that or to find the y, the x, I will start off with differentiating both sides with respect to x. So I'll put it down the derivative of x squared plus y squared, okay, to be the derivative with respect to x of 1. Good. All right. And then by using the sum rule, we are going to differentiate each of the terms. That would mean the derivative with respect to x of x squared, okay, we add it with the derivative with respect to x of y squared, and then we equate that with, well, the derivative of 1 with respect to x will just give us 0. Okay, good. And now we can just differentiate this, right? The derivative of 2x just by using the power rule, the derivative of x squared just by using the power rule, that will give us 2x, okay? And then we add it with, and now y here is a function of x given as 2x plus 1, okay? So this is how we are going to work with it. I'm going to replace the y over here with that 2x plus 1, okay? So in place of y, I'll just put down 2x plus 1, okay? All right, good. And then y has been squared, so I'm going to raise that to power 2. Okay, and then I'm going to differentiate it. Good. Put down to be equal to 0. Okay. Here, we want to differentiate a function of a function, all right? We have a squared function, okay, you can call it a power function, which is something raised to power 2, and that thing is a linear function. So that's a function of function. Using the chain rule, you're going to differentiate that. So here, I'm going to put this down as 2x, and then I add it with, well, to differentiate a function of a function, we are going to start off with, we differentiate the outside function, which is the squared, all right? So we differentiate this just as if we are differentiating a power function. We're going to bring the 2 down, okay, multiply it with the thing, that is 2x plus 1, and then we're going to subtract 1 from these 2, okay, so we subtract 1 from that 2. When we subtract 1 from 2, we get 1 as a power, right? So maybe let me just clean the power since it is just 1. Good. And then by chain rule, we are not done. That was just the derivative of the outside function. We are going to have to differentiate the inside function, right? And multiply it with that. So we're going to have the derivative with respect to x of the inside, which is 2x plus 1. Good. And then we equate this just to 0. Okay, great. And then the next thing I'll be doing is, I'm not going to expand this, all right? I want to show you that whenever we have to differentiate the y function here, we should multiply the derivative of y with something. So what I'll be doing here is 2x plus 1 and 2x plus 1. I'm going to put y in its place, all right? Remember we said y is 2x plus 1. So this means that we're going to have 2x, then plus, in place of 2x plus 1, I'm going to put y, right? So we have 2 times y times the derivative with respect to x of y, right? Good, and then we equate this to 0. So this tells us that whenever we differentiate x squared with respect to x, we're going to have 2x, okay? And then plus, which is here, when we differentiate y squared, okay, since y is a function of x and we are differentiating y squared in terms or with respect to x, we will differentiate this as a power function just by bringing the power to the front, multiply with y, okay, and then multiply it with, and now y is a function of x, okay, so we're going to have to differentiate y with respect to x. So whenever you're differentiating the y function, always endeavor to multiply it with dy dx, okay, and then we equate it to the right hand side. Anyway, let me clean this part of the board, and then we're going to rewrite this last equation at the top, and then we continue finding the derivative of y with respect to x. All right, and now we have the equation 2x plus 2y times the derivative of y with respect to x, and that is equal to 0 from the last part of the board, all right? Okay, good. Okay, and now we want to find dy dx, which means we have to keep this on the left-hand side and then try to make it the subject of formula, right? By moving every other thing to the right, okay? So I'm going to rewrite this as, just by moving this other term to the right-hand side, we're going to have the derivative with respect to x of y, right? That is just a way of writing dy dx. Will be equal to, well, let's do this in our head. We move this 2x to the right-hand side, that will become negative 2x, all right? And then, since this has been multiplied with that, to clear the product, we have to do division by 2y, all right? So I divide both sides there by 2y. That is just by making the subject of formula. Move this to the right-hand side, and then divide both sides by 2y. Good. Okay, so we say that these 2 and these 2 will cancel, and then we're going to enter with the derivative with respect to x of y to be equal to negative x over y. So this right here is the derivative of that function, okay? Just by using the chain rule, when we have y, you differentiate it, that will give us 2y, then we multiply it with dy dx, okay? All right, great. Now, in the next video, we'll be differentiating implicit functions, all right? Some good examples for you. Okay, all right. Let's just get right into it.